purposes, I feel like if you don't mind, I would like to review some of the old problems from previous times.
Yes.
But we don't have time to let you try every problem. And then does that make sense? We just don't. So I still think it would be beneficial if we went through them together. Does everybody agree or disagree?
Agree.
It's always helpful to see it again and again. Okay, so if you wanted to write them in your notes, you could. We're going to go quick because really this is just like, hey, let's look again at this. So from 1.1 and 1.2, we're going to be asked on the test exactly like this. Write something like this in radical form. I'm not saying it'll be this exact problem, obviously not, but the question will be the same. Write something in radical form. So we know that fractional exponents, if we want, can be written as a radical. We don't always want that. In this case, because of the instructions, we do. So let's rewrite this in radical format. We learned a trick. How do we remember the root? It's the bottom like a flower. Roots on the flower are on bottom. So we're going to go square root. Square roots don't write 2's in. So I'm going to leave it blank. If you did write a 2 on the test, that's fine. But we all understand a blank root is a square root. Then what should I do next? The power is 1, yeah? 1. And then 10 and x to the third have their own powers. So I could write this, couldn't I? 10x to the third to the 1? Yeah, so we could write that. That would be an acceptable answer on a test. Now, you make a good point. There is another way to write this answer that would be acceptable on a test. A lot of us understand that if we have an exponent of 1, it is not necessary to write that 1. So you could go 10x cubed, true? Same answer, you've just written it in a different format. Both are acceptable formats. Moving on. So don't talk in between. We don't have time. Okay. Moving on to this one. These ones look harder than they are. I am asking you, please do not let your brain go, oh, this is hard. Look at this and say, I just need to simplify this in sections. Now, your section might be different than your section. So pick what you want to do. I like to, this is just me, I like to simplify the top, simplify the bottom, simplify the whole thing. But that's not always the best way. So you do what's comfortable for you. So if I just focus on the top, I understand if I look inside here, it's all multiplication. Would you agree, yes or no? Yes. Multiplication can be reordered in any order. So me, for the video, I'm going to show my work. I technically have 3 times 2. I like to go like this so I don't miss anything. Then I have an x to the 0. To me, that is not necessary to write. X to the 0 power becomes a 1. Yes? Yes. Moving on. I still have on top an x to the 1/2. And that's the only x's I have. I like to put my x's by each other and my y's by each other. So then I have a y to the 1 and a y to the -3/2. We all understand when the y has no power, it is a power. It's a power of 1. Then I say to myself, okay, the top isn't super simplified. I just reordered it. Now I can simplify it. Math is math. 3 times 2 is 6. X to the 1/2 had nothing happen to it. When you multiply the same base, we do what with our exponents? We add them. So I go off to the side. This is just my personal choice. And I say, okay, I've got to add this fraction together. So I go like this, 1/1 minus 3/2. I then understand how to add fractions. We get a common denominator and then add the numerator. So if I were to add the numerator at this point, aren't I getting -1? So I'm going to write y to the -1/2. Then here I focus on the bottom. So I say, okay, I guess I'm going to do, if I decided to go this route, 12 times 3. Then I have an x to the 1. And an x to the -1, yeah? Then I have a y to the -2 and a y to the 2. All right, so then I would say 12 times 3 is, I guess if I'm going to do that, 36. When you multiply, you add. What's 1 plus -1? So we have x to the 0. Right here, when you multiply, you add. So we have y to the 0. So then from here, we know that any base to the 0 power is a 1. So this becomes 1, this becomes 1. I then say, does my answer simplify? Math is math. Does 6 and 36 divide? It divides out to be 1/6. Yep, 1/6. Then I have an x to the 1/2, and that's a positive exponent, which is considered a simplified answer. When we see a negative exponent in a final answer, it's just not a pretty final answer. There's nothing mathematically wrong with it. It's just the answer isn't written as pretty as it could be. So we take the base and we flip it over the fraction, yes? Yes. All right, so the answer would be this. we're good to go. Now, obviously, we all understand, do we have to write the 1 on top? No, so I'm not going to rewrite it. You get the point. I would also accept x to the 1/2 divided by 6y to the 1/2. That's not an intimidating problem, as long as you tackle it in sections and you're just careful. Okay, so right here, do we need to see another one like that, or do you feel like you get the picture? It's up to you guys. Do you want to see this one? Yes or no? Raise your hand if you'd like to see it. Let's just skip majority rules. Okay, that's not enough. Moving on then, great. If you needed to see that, that's fine. We could always go over it at the end. Now remember what we learned last time, 1.3. We learned that the square root of -1 is mathematically equal to I. 1I, essentially. So we just maybe, we thought you had learned that in Sec 1 honors. If not, then sweet. You now need to memorize that. The square root of -1 is mathematically equivalent to I. I is the more simplified answer. So if you ever see a square root of -1, it's better to write it as I. Make sure you're not the person that writes square root of I. It's not square root of I. I is now no longer in the root. Okay, then everyone has to remember that is not the case for odd roots. The cube root of -1 is not I. The cube root of -1 is just -1. So even roots have imaginary answers when there's a negative underneath. Where odd roots do not have imaginary answers, they just have negative answers. The negative always gets pulled out of the radical. It is always more simplified to pull the negative out and either make an I or a negative on the outside. Is that helpful? Yeah. Okay, so looking at this problem right here, it says simplify. So we're square rooting. We are square rooting -24. We're square rooting x squared. We're square rooting y cubed. We're square rooting z to the 8th. We're square rooting p to the 7th. I like to do a mixture of writing out the factors and not. To me, it's too big of a pain to write out 2 z's, to write out 3 y's. But I do believe it's helpful for numbers. So I'm going to go like this. I know this is -1 times 6 times 4. Then I'm going to say that's -1 times 3 times 2 times 2 times 2. I then check before I move on. Is -1 times 3 times 2 times 2 times 2 24? I didn't mess up. Then I go, okay, and I just have x squared, y cubed, z to the 8th, p to the 7th. Now we know if we were to draw out 2 x's, we're pulling out groups of 2. If we write 3 y's, we're pulling out groups of 2, right, everybody? If we write out 8 z's, we're pulling out groups of 2. So we're going to use that knowledge to make our life easier. So now what I'm going to do is say, okay, groups of 2. Because I did the factor thing, I need to pull out groups of 2. So looks like this is a group of 2. So this is going to come to the outside of the answer. So I write a 2. I then have a square root of -1, which is? Imaginary. Yep, I, okay? Then I say, okay, so I personally like to write in my square root and write what's left underneath when it comes to the numbers. Isn't 3 left underneath and 2? Yes. You multiply it back together, so it's 6. Now, I don't want to write out 2 x's, so I just say, I know I'm pulling out groups of 2. So how many groups of 2 are there in x squared? 1. There's just 1 group, which means I have x to the 1. Do you guys see? 1 group of 2. Okay. Then I move on, and I say, so that took care of that. Then I say, how many groups of 2 are there in 3? 1. Just 1. So I go y to the 1. Now, how many then y values will be left under the root? 1. Just 1. Now, if you're like, well, why just 1? Then you need to once again go over the visual aid. See, when we pull out that, it's just 1 y. But we technically pulled out 2 y's, right, everybody? Because it's groups of 2. We only write y because we're square rooting it. Okay, sweet. Then how many groups of 2 are there in 8? 4. So that would be z to the 4th, okay? Oh, okay, we're doing good. Yeah, we didn't mess up. And how many groups of 2 are there? Stop with the tapping. Stop with the tapping. You're killing me. All right, so how many groups of 2 are there in 7?
3.
So you would then say, so I'm pulling out a y cubed. How many then remain?
1.
Why did I say y again? Isn't it variable p?
Yeah.
Sorry, don't fret, don't fret. We're going to write p. So you're saying that there's actually 2? 2? 3 groups of 2. Okay. And then remaining then would be 1p. That would be the final answer. Now, yes, you do not have to write the 1s as the exponent. It's the same answer if you do, and it's the same answer if you don't. Now, I also need you to understand, I can be written after the, don't erase the whole radical. It's okay. So I can be written after the radical. It can be written in front. It's just more common that we see it written in front.
Wait.
But let me show you. It doesn't matter order. Isn't multiplication any order?
Yeah, but you said you could write it after the radical?
Yep.
Like behind?
Yes, because it's just times, right? Isn't this a time sign?
Yeah.
As long as it's not under the radical, we're good. So you're going to see sometimes on an ACT an answer written as like 2i roots of 2, and you might see 2 roots of 2i. That's the same answer. It just put I in a different location. Multiplication can be in any order.
Yes. Yeah,
It shouldn't confuse you now. That makes sense. How could they also write it? I root 2, 2. You know what I mean? That's not how they're going to write it. But my point is multiplication can be reordered in any order. All right, I think we get the picture. I'm not going to do this one. However, are we going to have an I as an answer? No, we'll have a negative on the outside. True? That takes care of that. And then we'd pull out groups of 3. Okay, I think we get the picture. We're going to move on. We also learned how to add complex numbers. Complex numbers have real parts and imaginary parts. You add real parts to real parts, imaginary to imaginary. So this was super straightforward. Negative 2 plus 4 is 2. 3i plus negative 2i is 1i. Yes, you don't have to write the 1. We all get that picture by now. I'm at a certain point going to stop saying that. Okay. We have to be careful with subtraction. We don't want to be that person that gets tricked by subtraction, meaning you just make a small mathematical error and you're kicking yourself on the test because you missed an easy problem. We know that since this is a negative 1, both of these are being multiplied by negative 1. So sometimes it's a good idea that you don't make an error to rewrite that. This has parentheses, but nothing is happening to the parentheses. So I'm just going to rewrite them. They are not changing. But now I have negative 1 times negative 2. Isn't that plus 2? So I write plus 2. Then I do negative 1 times negative 1 times positive 2i, which would be now negative 2i. Then you combine real parts with real parts. 3 plus 2 is 5. Negative 4i minus 2i is negative 6i. Yes, hand over here.
So, I know you could do the 1 to distribute, but also you could just like do the negative over, right? And just do the double negative as a plus 2.
Yep.
Right?
You're just thinking differently, right? But you're doing the same thing. Yes. All right, good. Let's move on to 1.4. So if we are good, this is actually how I normally teach. We're going to try it out today. The reason I haven't been doing it in the past is because you're not very good at then when I say coming back to me. People keep talking. This is going to help your learning if we can do what I normally do. So let's give it a try. Let's see how it goes. Round 1. 1.4, you're taking notes. Ready? Let's do a little. Oh, that sucked. All right, here we go.
Yeah,
Oh, but remember,
it's hard to do.
hey, remember you're not supposed to talk after the clap clap.
I like 1,
Let's
2,
try
I
again.
like
Yeah.
It's a lot easier to do like the.
Nope, it's not.
Because it
Disagree.
More attention. When you just do 2, it doesn't get their attention. And just
Guess
goes
what?
flat.
In my other class, all I have to do is go, all right, and it's dead silent. So we're good. All right. All right, freaking A. All right, here we go. Don't talk. Do not talk. You're going to, literally, I'm not kidding. If you do not stop some of you from not being able to be quiet when I'm teaching, it's distracting for some kids. I've already had parents say, like, my kid feels distracted in your class. That's not okay. So if that's the case, my friends, I'm going to make you go and take Mr. Jones, which is fine. He's a great teacher. But I'm just saying you won't be in here. All right, 1.4, complex numbers. You guys also should be taking notes. Now, on a note taking, can you write down everything? No, you don't have time for that. You write down the key things. All right, so we're going to learn how to graph a complex number. In your notes, maybe write this. It is very straightforward. We all know how to graph a point. It's the same idea. The x-axis is the real axis. That's where we go for real numbers. Where the y-axis, what we normally look at as y-axis, is considered the imaginary axis. So what we do is we graph just like your intuition would tell you. So watch me graph this right here. 2, negative 3i. What is the real number? So I'm going to go 2 values on the real axis. So where would that be? Right there. True, everybody? Yeah. And then it's just 2. You guys, 2, right? Go over 2. If it's negative 2, you go negative 2. Okay? We're not overcomplicating this. And then we're going down 3i. Why down? Because it's negative. Go negative on the y-axis because it's the imaginary axis. So we're also going down 1, 2, 3. Boom, there's the point. Right 2, down 3. It's just an XY point essentially. Everybody, right 2, down 3. Right 2, down 3. Yes, what's your question?
Would it still be the same if negative 3i was in the front?
Yep.
Okay.
Exactly. So you make a very good point. If we had negative 3i plus 2, we know that this is the same answer as this, and so it would graph the same. Good question. All right, now look, tell me what the red point is as a complex number.
Starting point, right?
The whole complex number. So right there, what point is that? Let's write out. It's negative 2 up
Positive 2i.
2. Okay, so let's write the complex number. We would say negative 2 is the real number. True?
Yes.
And then the complex part is
2i.
positive. So you'd say plus 2i. Don't overcomplicate it. So now listen to what I'm saying. You are allowed to talk on 1 through 4 as you do them. But you need to work quick. Are you going to necessarily get done with 1 through 4? No. When I clap, we're moving on. And you would then do the rest of 1 through 4 at home. Do you understand?
Yeah.
All right, ready? I'm going to give you a couple of seconds to try a few in 1 through 4. Ready, go. Now you're allowed to talk for a second.
Shucks.
Then you're going to wait. Just quietly wait. Cool. So this is a good time to say to the person next to you, I don't understand. Help me. Oh my heck, totally forgot about you. So, I literally forgot. Okay. She did. Oh, you're doing a 2 regular? Okay, sounds good. I was gonna say she doesn't teach 2, but she does. She teaches 1 class of it. They just tried to have a kid switch in from 2 honors to 10 pen. I'm like, it doesn't work that way. It doesn't. You gotta go to this. But you're good. Okay. Yep.
Oh yeah, that is your pass.
Oh yeah. Okay. Perfect.
Guys was giving me straight up PTSD.